Hello everyone. Since there's a mix-up on Connect Math about the videos for section 12.7, and then let's go through this section through my video. And this is a 12.7 applications on normal distributions. The difference between this section and the previous section except empirical rule problems, which about whole number of standard deviation. Most of the questions we practice and with a z-score given. And in this section, we're dealing with actual data value. And this will be the steps we are going to follow to solve application problems. I summarize about 5 steps. The first step, you are going to draw a normal curve for each part of the question. So we cannot be lazy on your scratch paper. You need to draw one curve per part. And if you try to use one curve for all parts with your label, that can get confusing at some point. So try to draw a curve for each part. And then we find z-score for the given data value, and now we're going to go to the table. Look up the table with the z-score you just found, and then we get back to the program and to the diagram, and eventually we answer the question. Okay, let's get started. This question, so I used one question with many parts to cover every possible scenario you can expect on the test as a question for normal distribution. Okay, the question given here is the mean for a reading test given nationwide is 80. So the mean score actually is given as 80. And the standard deviation is 8. The variable is normally distributed, and this must be mentioned so that we can use the property ideas through normal distribution. As you can see, I drew a normal curve for each part of my questions. And the first one, they ask you, find the percentage of the students who scored over 90. As a normal distribution, as we mentioned in the middle, this is the mean. The mean is 80, so we're going to put 80 here. And then where is 90? 90 must be above 80, so 90 must be to the right of 80. This is my 90. I draw a line for the mean, I draw a line for my data value, at the data value. And I read the question, it says, who scores over 90? And I need to shade the question region. Over 90 means above 90, means to the right side of 90. Remember, 80 is my mean and 90 is my data value. The next step, we need to go to find z-score. And the z-score is given as data value, subtract the mean, and divided by standard deviation. So we have data value as 90 minus 80 divided by 8, because the standard deviation is 8. Once we work this out, this is going to be 10 divided by 8 as 1.25 as my z-score. So next step, we said with this z-score, you are going to go to the table. So let's go to the table. As you can see, I butchered this table pretty good so that I only include what I need. And let's try to understand this table. All the table value, there are two big columns, z column and the a column. Based on the z-score, and you have an 8 value, which is the area under the curve between z equals 0 and the positive value z. Earlier, the first part, we have 1.25 as my z-score. 1.25 is right here, and there's a given 8 value. What does that mean? That means it's the area between z equals 0 and the 1.25, right? So remember that, keep that in mind. We're going to go back to the diagram. I would like to label this. Within the diagram, I would like to label this value within the diagram. Okay, let's go back. And if I were to label 0.394 in the diagram, where would that belong? Remember, the title of the diagram says it's the area between z equals 0, which this is z equals 0, and the positive value of z, 90. At 90, the z-score is at 1.25. So in this region, right here, is actually 0.394. Between z equals 0 and the positive value z. But that's not my question region. My question region is shaded in red. So what do? We also know from the property of a normal curve, we get to know half of the graph contains 50% of the data. So if I know 50% to one side of the mean, and I know 0.394 here, what about there? Can you see we're going to use a 50%, subtract this region to get a shaded region? So to answer the question, I'm going to move over. I'm going to move over here and write my answer here. It's going to be 0.5 because that's one side of the mean as a 0.5. Subtract 0.394. And this is going to be 0.106. Remember the question asks you to find the percentage, so the format of solution expected here will be a percentage as 10.6%. That's the first part. Okay, let's go back to the question, review this quickly again. And we need to find the percentage of the students who score over 90. Over 90 means more than 90. So therefore, I shaded this region as more than 90. From the diagram, after we do the diagram, we said we need to find z-score. Z-score is defined as data value minus mean, subtract, divided by standard deviation. We found the z-score as 1.25. And after that, we're going to go to the table. Go to the table from 1.25. This is z-score. We comes with this 8 value. It comes with 0.394. 0.394 belongs to this region right here, between z equals 0 and a positive z. So if this portion is 0.394, the entire right of the mean as 0.5, then we get to know the difference as 0.106, which is 10.6% of the students scored more than 90. Okay, let's look at the next one. The next one, we're asking you to find the percentage of the students who score between 78 and 88. Okay, here, and first, I think, again, I'm going to go to locate my mean, which is right here, as 80. 78 is to the left, less than 80. 88 is to the right, because it's bigger than 80. And it says in between, so it must be here as my question region. Now I get 2 data values, so I need to find z-score for each. Find z-score for each. So here we go. We say z for 78 is going to be 78 minus 80 divided by 8. And z 88 is going to be data value, subtract the mean, divided by standard deviation. And 78 minus 80 is going to be negative 2 over 8. That's going to be negative 0.25, right? And this is going to be 8 over 8, which is 1. So first step, we completed our normal curve, the diagram. Second step, we find z-score. And the third step, we're going to go to the table. We're going to go to the table, look up z-score of 0.25 and 1. Now remember, on the table, it did say we only deal with a between z equals 0 and the positive value of z, right? Z equals 0 and the positive value of z. So what if I have a negative value? Well, if we have a negative value, we're going to make use of the property of symmetry. We say, what if I have a negative z? We say we can use a positive z to treat that. From positive z to 0, I can find the 8 value from the diagram. The property of a symmetry of a normal curve tells us, well, then this is going to share the same value. Therefore, when I go to the diagram, although I have negative 0.25, I can look at positive 0.25 as a 0.099 as my 8 value. So 0.099 has something to do with a z-score 0.25. Let's go back to the diagram one at a time. Okay, so we go back here. 0.25 or negative 0.25, it comes with a value of 0.099. And the 0.099, in fact, belongs to this region. So where does that belong to? In between these two values. So between 78 and 80. So if I have to write in there, it's going to be 0.099 in this region. Okay, next we're going to go to look at 1. And the 1 is right here. Z-score of 1 comes with a value of 0.341. 0.341 belongs to this region. It's going to be the region between 88 and 80, between mean and the data value, or z equals 0 and a positive z. So in this region, I have a 0.341. Can you see how we answer the question? So now I know the z-score, and now the z-score value for this region and the A value of this region. We really need to find the area of this region. Can you see we're going to add them together? Yes, we're going to add them together. And then we're going to add these values to be 0.099 plus 0.341. And I think they add up to 0.44 or 44%. Okay, this is part 2. And the part 3, the way I designed the question kind of make my life easier, because in part 3 it says let's find the percentage of the students who scored below 88. So 80 is still our mean. Below 88, 88 say is right here. Below 88 means to the entire left of 88. But remember we found the z-score for 88 earlier, which is 1, right? And then furthermore, we looked up table. The A value comes with a z-score of 88 is 0.341. So we say 0.341 actually belongs to this region. If I have to write into the diagram, which I do prefer to write into it, and that's a 0.341. What do you think how we're going to answer the question? We're going to make use of the property of the symmetry or the normal curve to one side of the mean. I have 50% of the data value, or 0.5 as the area under the curve, or 50% of the data to one side of the mean. Now can you see what we should do to answer the question? Yes, so we're going to add them together. So 0.5 plus a 0.341 is going to be 0.841, or we say is 84.1%. Okay, next one, we ask you to find the percentage of students who scored over 78. Okay, again, 80 is right here. 78 is less than 80, so to the left of 80. Over 78 means this would be the region I need to find the percentage for. And this is quite similar to the previous part. Can you see that? So 78, again, I kind of did myself a favor. 78, I did find z-score for 78 earlier in part 2, which is negative 0.25. And furthermore, I looked up the table and I found the A value as a 0.099. So 0.099 belongs to this region. And then can you see we have half of the curve left? And how would I answer the question? We make use of the fact that half of the curve contains 50% of the data, means to the entire right side of the mean, I have a 50% of the data. So therefore, we're going to add them together. 0.5 plus a 0.099 is going to be 0.599, or 59.9% of the data value is going to be to the right side of 78, or called over 78. Okay, let's look at next part. And next part, we ask you to find the percentage of the students who score less than 60. Okay, now I haven't seen 60 yet. 80 still is my mean. 60 is to the left of 80. 60 is less than 80, so to the left. And we ask you to find the percentage of the students who scored less than 60. Less than 60 means to the left of 60. After the diagram, we say next step, we're going to go to find z-score. We find z-score for 60. So that's going to be data value, subtract the mean, divided by standard deviation. Negative 20 over 8 is negative 2.5. And we're going to go to the table, look up 2.5, and then use the property of the symmetry. 2.5 is right here with a value as 0.494. So that a value belongs to between these two numbers on your diagram, which is right here, 0.494. This is going to be right here. So can you see how we're going to answer the question? We use the fact that to one side of the mean, the curve contains 50% of the data value. So we use, or 0.5 as the area under the curve. We use a total of a 0.5, subtract part to find the remainder, which is going to be the area in the shaded region. Okay, let's finish the question. I should have a 0.5 subtract 0.494, which is going to be 0.006, or this reads as 0.6%, sorry. This is going to be 0.6%. Last question, it says, if 1,000 students took the test, find the number of students. Now, if a sample size is a given, likely they're going to ask you to approximate the number of students who scored less than 60. So earlier, I found the percentage of the students who scored less than 60. This part really asking you, what is a 0.6% of 1,000? And I think we'll just multiply this out. We're going to have 0.006 times 1,000, which is 6. About 6 students scored less than 60. I hope this helps.